So welcome to today's video, and today we're going to learn how to make your first functions in R. So an R function is basically a block of reusable code that's designed to perform a particular task. And you're probably using functions every time you work with R, even if you haven't created one yourself yet. For example, you're probably familiar with the basic arithmetic functions like sum, which can be applied to find the sum of a vector, or mean, which can be applied to find the mean of a vector, like so. But creating your own functions can come in especially useful for tasks that you find yourself doing again and again. And there will likely be times when you come across such a task in your work for which a function hasn't been created yet. So that's probably why you're here, and good that you're here. So for the purpose of today's video, we're going to build 3 functions from scratch. First, we're going to build our own mean function. So one which computes the mean on a numeric vector. Then we're going to create 2 slightly more complex functions. So one which computes various summary statistics on a numeric vector. And then finally we're going to create a function that takes a person's height and weight as input and returns a BMI. So let's start with this mean function. Let's call it getMean. And basically, to create a function in R, we use this function notation. And we have these brackets, and whatever we're going to be applying our function to will go within these parentheses. And the code that we use to actually create our function is going to go within these curly brackets. So in this case, we're going to be applying our function to a vector. So we're going to compute the mean of a vector. So let's create such a vector, and let's call it v1. So within our function, the thing that we are going to be actually returning at the very end, or outputting, requires this return notation. So we want to be ultimately outputting the mean. So we'll write return mean. And then in the rest of the function, we want to compute that mean. So how do we compute the mean? We know that the mean is the sum of various elements divided by the length of those, or the number of elements in the vector. In our case, we're going to be applying the function to a particular vector, and this is why we place vector here inside the brackets of the function. In our case, the vector we're going to be testing out the function on is this vector v1. So the mean is the sum of the numbers in vector divided by the length of the vector. So these are the 2 values that we're going to need to know: sum vector and length vector. And then, so we're going to compute the mean by saying mean equals sum vector over, or divided by, length vector. And so now we no longer need these parts, and this is basically our function for computing the mean. So let's run that code. And then let's just test that function out. So let's apply it to our vector v1. So let's say get.mean v1, and our result is 6.2. So looks about right for our vector. Okay, great. So the next thing that we're going to try out is to create a second function. So this first function was very basic. This time I want us to create a function that takes a vector, we can use v1 again, as input, and then computes various summary statistics on v1. So by summary statistics, I mean things like, yes, the mean, the median, the sum. There are things like the minimum and maybe the maximum values in the vector. So how about we try to create a function that computes all of these different summary statistics and returns them all in the form of a list. So let's use the function get.summary statistics. So let's call it get.summary_stats. And again, we'll use this function notation. So function with parentheses. So we're going to apply it to a vector once again. And once again, we're going to use these curly brackets to make it a function. And so what we'll do is, first of all, compute these different statistics. So there are different functions for each of these statistics already made. So we can do mean is mean vector, sum is sum vector, median is median vector, minimum is, so for this we use min vector, and then maximum is max vector. Okay, so here we've computed all the different summary statistics, and what we want to do is return all of these values in the form of a list. So as before, we end our function with this return notation. And so in this case, we want to return a list. So list, mean, median, sum, minimum, and maximum. So this would return a list of all of the values that we've computed on our numeric vector. Maybe we also want to name these elements, so we want to know which is which. So in our list, we can specify mean equals mean, and this will give the name of the element. So mean equals mean, median, sum is sum, min, let's say, is minimum, and max is maximum. Now let's run this code, and again, let's try to apply it to our v1 vector. So get.summary_stats, v1, and as we can see, we've now outputted a list with the values for mean, 6.2, median, 6, sum, min, and max. These all look just about right for the vector that we created, v1. Okay, so now let's move on to our third task. So what I want to do is to create a function that computes a person's BMI. So this function should take a person's height in meters and their weight in kilograms. These should be the two input values, and then it should return the body mass index, so the BMI score. And it should also comment on that score. So what is the BMI? The BMI is a statistic that's calculated as the weight of a person in meters divided by the height of that person, the weight in kilograms, divided by the height in meters squared. Meters squared. Okay, so first of all, let's make a very basic function. Let's call it BMI. So BMI, again, is function in these parentheses. So this time inside these parentheses, we need two values. Previously, we just specified vector because we were applying everything to this one vector, but this time we need both the weight and the height. So let's write function HW, so this will be height, weight, and then again with our curly brackets, and then let's basically just compute the BMI and return it. And then we'll add some complexity later. So BMI is going to equal to W divided by H squared. And then let's say that's all for the moment, and let's just return that BMI and see what it gives us. So let's run this function. So to create the function, and then let's test it out. So let's test it out on a person. So BMI on a person who is 1.75 meters tall and who has a weight of 70 kilograms. Okay, so we see that this person has a BMI of about 22.8. But this isn't very informative, and let's say the person who is using this function doesn't know what a BMI means. So what we want to add is a little bit complexity. So we want to add some kind of a comment within the function that not only reports the BMI of the person, but also tells you what that means. So BMI is basically a tool to calculate whether a person is overweight, underweight, normal weight, or obese. So the thresholds are basically if the BMI is less than 18.5, a person is considered underweight. So let's say normal is greater than 18.5 and less than 25. And then overweight is considered if a person is greater than 25. And then obese if the BMI is greater than 30. So let's try to add something within our function which, once it's computed the BMI, it also checks whether the BMI is within the normal range or whether the BMI is representing underweight, overweight, or obese. So for this, let's introduce what we call an if statement. So we want to ask if BMI is less than 18.5, then the person is underweight. So we can say if BMI is less than 18.5, category is underweight. And then let's specify for each category whether one is normal, overweight, and so on. So here we can use else if BMI is greater than or equal to 18.5 and BMI is less than 20, less than or equal to 24.9, then the category should be normal or healthy. So category is healthy. Let's introduce another else if. So else if BMI is greater than or equal to 25 and BMI is less than or equal to 29.9, let's say, then category is overweight. And then finally, let's add one final else if statement. So else if BMI is greater than or equal to 30, we want to say, BMI is greater than or equal to 30, then category is obese. So now that we've defined these 4 different categories, we want to return these categories together with returning the BMI itself, so that when the function is computed, the user will get an output of the value of the BMI and also a comment about what that means. So let's say return a list where we have 2 values in the list, one BMI, let's call it BMI, and then category equals category in a list. And then let's run this code and let's try it out. So for this person, we see that their BMI is around 22.8 and their healthy weight. And if we change this value of the weight in kilograms, we see that if this person were 50, they would be underweight. If they were 80 kilograms, they would be overweight. If they were, say, 100 kilograms, they would be obese. So now we've made our function a little bit more informative. Okay, so one more thing that we could consider in this function is, okay, so hold on, let's see, what have we done so far? We've computed the BMI, we have defined the category, so what that BMI means, and then we've returned, so we've outputted the BMI and the category, BMI and category. One more thing that we could do is we could consider to check whether the input values are meaningful. So it could be that the person accidentally inputs their height in something that's not meters. And this would be very easy to detect, because if the height were like very low, if it were like less than 1, or if it were very high, then maybe the user inputted their height in centimeters or in inches or something else. So to do this, we can introduce kind of a warning. So again, we can use this if statement. And how about we say, if the height is less than 1 or greater than, let's say, 3 or even 2.5. So if the height is in this kind of abnormal range, then we want to return a warning. So we can use this warning function. So warning, and let's write something like, height appears to be in an unusual range. Please ensure you specify your height in meters and weight in kilograms. Okay, so let's try to run this function with this new warning statement. And now let's say if we were to compute or try to compute the BMI on a person who had inputted their height as being, let's say, 3.7 meters, then we would return this warning statement. Height appears to be an unusual range. Please ensure you specify your height in meters and weight in kilograms. Okay, great. So far, we've learned how to create simple R functions. And so we've computed mean, we've computed summary statistics, and we have this final BMI function. So hopefully you have a bit of a better idea now about how functions can be computed in R. And maybe you can start to create some of your own. So thanks a lot for watching.